Welcome back with a new math tutorial. In this video, we'll know how to write the recursive formula for the geometric and for the arithmetic sequence. So the first point in our lesson today, find the first 5 terms of each of the following sequence. If a1 equals 7, we said a1, which is defined by the first term, and the formula that we have, an equals an minus 1 minus 12, where n is greater than or equals to. We need the first 5 terms, as we know that a1 is equals to 7. Now we need to find the second term. Second term defined by a2. And instead of n, replace it with 2. And we use this formula. So now we can say a2 is equals an minus 1, which is equal a2 minus 1. a2 minus 1, which equals a1. a1 minus 12. Now by using substitution. So a2 is equals. a1 is equal to 7 minus 12. Then we can say that a2 is equals negative 5. So the first value that we have, a1 equals 7 and a2 equals negative 5. Now we need to find the third term. The third term, which is a3. a3 is equals a3 minus 1 minus 12. We know that 3 minus 1, which equals 2. So it will be a2 minus 12. Now by substitution. So we can say that a3 is equals a2, which equals negative 5 minus 12. Then we can say that a3 is equals negative 17. Now we can find a4. By using the same formula, a4 is equals a4 minus 1 minus 12. 4 minus 1 is equal to 3. So we use the formula, the given formula, an is equals an minus 1 minus 12. Where n is greater than 2, we use all of the values which is greater than or equals to find the first 5 terms of the sequence. So now by substitution, so we can say that a4 is equals, a3 is equal negative 17 minus 12. Then we can say that a4 is equals negative 29. Now we need to find a5. a5 which equals a5 minus 1 minus 12. Then 5 minus 1 which equals 4. So we'll use the fourth term. So a5 is equals, a4 is equals negative 29 minus 12. Then we can say that a5 is equals negative 41. And that's how we can find the first 5 terms of the arithmetic sequence. Find the first 5 terms of the sequence a1 equals 3 and an is equals 4an minus 1, where n is greater than or equals to. As we know that a1 is equal to 3. That's the first term. Now we need to find the second term. The second term, which is equals a2. Then we can say that a2 is equals 4a 2 minus 1. At this sequence, or at this formula, we can find the second term. 2 minus 1, which equals 1. So it will be 4 times a1. By substitution, then the second term now is equals 4 times a1, which equals to 3. Then we can say that a2 is equals 12. Now we need to find a3. By using the same formula, 4an minus 1. So it will be 4 multiplied by an minus 1. I need the third term. So 3 minus 1. 3 minus 1, which equals 2. So we need 4 times a2. Now by substitution. So a3 is equals 4 times 12, which equals 48. Then we can say that a3 is equals 48. Now we need to find a4. We can use the same formula, which is 4a n minus 1. We said n is equals to 4. So instead of n, I replace it with 4. 4 minus 1, which is equal to 3. Now by substitution, then a4 is equals 4 times a3, which is 48. 4 times 48, then a4 is equals 192. Now we can find a5. a5, which is defined by 4a5 minus 1. 5 minus 1, which equals 4. All of that we can find it from the equation an is equals 4an minus 1. Then now we can use substitution. So a5 is equals 4 multiplied by 192. Then we can say that a5 is equals 768. In this problem, we need to find the first 5 terms of the sequence a1 equals negative 2, where an is equals an minus 1 plus 4, for n is greater than or equals to. From the given, we know that a1 is equals to negative 2. Now we need to find a2. By using the formula, an is equals an minus 1 plus 4. For each n, replace it with 2. So to find now, 2 minus 1 equals 1, so it will be a1 plus 4. So we can find a2, which equals -2 plus 4. Then we can say that a2 is equals to, that's the second term. Now we need to find a3 by the same way, an minus 1 plus 4. So a3 minus 1, which is 2, plus 4. By using substitution, then a3 is equals, a2 is equals to, plus 4, which equals 6. Then we can say that a3 is equals 6. Now we need to find a4. a4, which equals a4 minus 1, which is equal a3. a3 plus 4. We'll use all of the previous to find the next one. Just use the answer and add it 4. So it will be a4 is equals 6 plus 4. Then you will find that a4 is equals 10. Now we need to find a5. a5 is equals a4 plus 4. Then it will be a4 is equals 10 plus 4. Then a4 is equals to 40. And that's how we can find any number of terms for any recursive formula. In this part of the lesson, we'll know how to write the recursive formula for the arithmetic and geometric sequence. We can start with the arithmetic sequence. To write the arithmetic sequence, at the first I need to find a1. After finding a1, then we can use the formula an is equals an minus 1 plus d, where d is the common difference, and n is greater than or equals to. That's defined by the domain. Now we need to find for the geometric sequence. For the geometric sequence, at the first we need to find a1. Then after that we use the formula an is equals r times an minus 1, where n is greater than or equals to. In this problem, we need to write the recursive formula for the sequence 6, 24, 96, 384. At the first, to write the recursive formula, we need to find if this sequence is arithmetic or geometric. If you look at the sequence or the pattern, you will find that in each time you multiply it by 4. Because you multiply the same number in each time, it will be geometric sequence. So because of that, I will find a1. a1 which equals 6. And we need to find the common ratio. The common ratio is the number that you multiplied each time, which is 4. Now we need to write the recursive formula. As we said, it will be geometric sequence. So the formula for the geometric sequence an is equals r times an minus 1. So to write it at the first, I need to say a1 is equal to 6, where an is equal, by using substitution, r is equal to 4 multiplied by an minus 1, where n is greater than or equals to. It means all of the values that you use instead of n must be 2 or more. All of them must be integer, and all of them must be 2 or more. Write the recursive formula for the sequence 4, 10, 25, 62.5. At the first, we need to find if this sequence is arithmetic or geometric. If you look at the pattern, you will find that you multiply each time by 5 over 2, or 2.5. So we multiply each time by 2.5. It means the first term now will be 4, and the common ratio will be 2.5 or 5 over 2. Now we know that an is equals, because its geometric will be r multiplied by a times n minus 1. Now we can write the recursive formula, which is a1 equals 4, where an is equals r, which is 2.5, times an minus 1, where n is greater than or equals to. In this part of the lesson, we'll know how to convert between the recursive formula and the explicit formula. So we need to write the recursive formula for an equals 6n plus 3. Because we have adding or subtracting, it will be arithmetic sequence. For any recursive formula to find it, we need to find a1 and d and an. Because we have here 6n plus 3, it will be arithmetic sequence. So we can write an is equals an minus 1 plus d. And that's the formula for the recursive formula for the arithmetic sequence. Now we need to find a1. To find a1, replace n with 1. So 6 times 1 equals 6 plus 3 equals 9. Now the common difference between them will be the coefficient of n, which is 6. Now to write the recursive formula, we start with a1. a1 is equals to 9. Then write the formula. an is equals an minus 1 plus d, where d is equal to 6. Then, where n is greater than or equals to, we need to write a1 and the formula and the domain of the recursive formula. In this problem, we need to write the recursive formula for an equals 4 times 3 to the power n minus 1. Because we have a power, it means we are talking about geometric sequence. The formula for the geometric sequence an is equals r multiplied by an minus 1. Now we need to find a1 and we need to find r. To find a1, all what we have to do, just replace n with 1. So 1 minus 1 equals 0. So to find a1 will be 4 multiplied by 3 to the power 0. 3 to the power 0 equals 1. 4 times 1 equals 4. And that's the value of A1. Now we need to find the common ratio. The common ratio, which is the base. The base now is equal to 3. So we can write the recursive formula. At the first, I need to find the value of A1, which equals 4. Then after that, write the formula. AN is equals 3 multiplied by AN minus 1. After that, write the domain. So n is greater than or equals to. Is always n is greater than or equals to. Write the explicit formula for A1 equals 120. And AN is equal 0.8 multiplied by AN minus 1, where n is greater than or equals to. From the given formula, we have 0.8 multiplied by number. When you multiply by number, it means you are talking about geometric sequence. When you add, you are talking about arithmetic sequence. We need to write the explicit formula. The explicit formula for the geometric sequence is AN is equals A1 multiplied by R to the power n minus 1. That's the explicit formula for the geometric sequence. We need now to find A1 and we need to find R. What is the value of A1? A1, which is 120. R, the common ratio. The common ratio, which is 0.8. The number that we multiplied by AN minus 1. So it will be 0.8. Again, to remember the difference between them, we have two formulas for the geometric sequence and two formulas for the arithmetic sequence. The explicit formula for the geometric sequence, AN is equals A1 times R to the power n. And the recursive formula will be AN equals R multiplied by AN minus 1. Now we need to write the explicit formula. The explicit formula will be AN is equal A1, which is 120, times R, which is 0.8 to the power n minus 1. That's the difference between the explicit formula and the recursive formula. The explicit formula will be AN is equals A1 times R to the power n minus 1. The recursive formula, both of them for the geometric sequence, will be AN equals R multiplied by AN minus 1. Write the explicit formula for A1 is equals negative 16 and AN is equals AN minus 1 minus 7. Look at the formula that we have. AN minus N minus 7. Because we subtract, it means we are talking about arithmetic sequence. For the arithmetic sequence, we have two formulas. The first one, AN is equals AN minus 1 plus D. And the second one, AN is equals A1 plus N minus 1 multiplied by D. What is the difference between them? The first one defined by the recursive formula. When I ask you to write the recursive formula, you have to write AN is equals AN minus 1 plus D. And that's depend on the previous term. Now to find the explicit formula will be AN is equals A1 plus N minus 1 times D. So at the first, we are talking about arithmetic sequence. To find the arithmetic sequence, we need to find A1. What is the value of A1? From the given A1 is equal to negative 16. And we need to find the common difference. The common difference between them, and each time you subtract 7. So the common difference is negative 7. Because we said it's written in the form of AN equals AN minus 1 plus D, where plus D is the common difference. Plus D, which equals negative 7. So D is equals negative 7. Now we need to write the explicit formula. So it will be AN is equals A1, which is negative 16 plus N minus 1 multiplied by negative 7. By using distributive property, so AN is equals negative 16. Negative 7 times N will be negative 7N. Negative 7 times negative 1, it will be positive 7. Then we can say that AN is equals negative 7N. Negative 16 plus 7 equals negative 9.